and welcome. My name is Sudheer Matte, and this is the new wireless network with AI in action. Today we're going to talk through what is AI, what does it mean, how can it help IT, especially in networking, and also for the business folk that are trying to digitize their enterprise. AI has a lot of buzz around it, and there's a lot of imitations. And so let's get the facts straight. So this is about first setting the context, what are the definitions, get them right, and see them in action. All right, here we go. So artificial intelligence is the field of being able to have machines develop perception, cognition, and take action similar to humans, right? Machines being able to understand normal human language, speech recognition, cognition, then take the natural language, process it, and put it through some neural networks and machine learning algorithms, and then be able to take action just like a human. In 1950, a very famous scientist, Alan Turing, came up with the best test for what is an AI-driven system. It's called the Turing test. The Turing test is basically if subject C here, let's say that's a person, is talking to A or B. And if C can't tell the difference between when he's interacting with the machine A or a human B, then we've mastered the art of AI. So the Turing test is what we're going after. And I'm going to show you some examples of how MIST is driving AI into networking based on this particular test. And then there is machine learning. So what is machine learning? Machine learning is the ability of machines to learn without pre-programming. We at MIST use unsupervised machine learning, and I'm going to talk a little bit about that. But there is supervised machine learning. Supervised machine learning is, let's say we feed a 1,000 or 1,000,000 images of a picture of a cat to a system, and then we present another picture, and if the machine is able to detect the picture of a cat in that, that's what learning is without pre-programming. There is a lot of study and scientific effort going around and industry effort, and I'm going to give you examples of machine learning in our everyday use. And then there's deep learning. If you think of human perception, we open our eyes and we see the world around us. Millions of pixels are being processed by our central nervous system, the neurons in our brains. Every second, we're processing so much data, and that's a multi-layer neural network running in our brain, and we're trying to emulate that using machines. And we're nowhere near emulating a human brain, but we're getting oh so better at it. And I'm going to show you examples how deep learning is starting to take foot in our daily lives. And then what is data science? Data science is basically a little bit of artificial intelligence, a little bit of machine learning, some deep learning, and some of data science is just pure statistics and analytics and analysis and data mining based probability and predictions, right? So data science is a little bit of this whole cognition, machine learning, neural network stuff, and then a little bit of pure stats and data mining. But it is huge, it's important, and we're going to show examples of that as well. Now before we go into networking, let's start with some generic examples of how we're using these in our daily lives. So Amazon Alexa is probably the best example of being able to process natural language queries and being able to process them and take action. It's just a beginning. There's Apple HomePod, Google Home, all kinds of Siri, Cortana. Everybody is trying to get into this game because this is the next frontier. right? So, instead of, just getting off my couch and walking up to my thermostat and setting temperature, I could do something like, Alexa, set my downstairs temperature to 72 degrees.
The AC is set to 72.
So being able to understand, process, and take action, that's AI. That's beautiful. Now, machine learning is the Nest thermostat in our house detecting and saying, hey, everybody seems to have left the home, the kids are gone to school, the parents are off to work. Now I'm going to go into my eco mode, which is basically I'm going to save temperature, save energy, because I don't see any movement in the home. And so I'm learning the pattern of when the kids are going to school, when the parents are coming home or leaving home, and taking action. That's machine learning. And then deep learning is what Tesla is trying to do. It is hard. However, trust me, deep learning and all this neural network stuff is coming to a car near you. It's going to happen. Self-driving cars are hard because Tesla, if you look at it, they're taking all the data from these sensors, real time, sub-second, they're able to process and make decisions on, should I stay in the course? Should I go to the right lane? Should I go to the left lane? Should I slow down? Should I speed up? All those decisions are happening because there are layers of neural network that are processing all this data and being able to take the right action at the right time. Now, what's an example of data science? This is the coolest one. The Warriors beat the Cavaliers in Game 1 and Game 2. So now, can I predict who will win the NBA Finals? I don't need, complex AI algorithms. I don't need complex machine learning. I may not even need deep learning. I could say, you know what? History says 90% of the time, the team that wins the first 2 games of the NBA Finals will go on to win the title. I'm so glad the Warriors beat the Cavaliers, but, we were able to predict that right after Game 2 and didn't have to wait like LeBron did till the end of Game 4, right? So data science is a little bit of data mining, but a combination of all of these, right? This is coming to networking. Let's first talk about why do we need all of this? Here's some truisms in our industry. The number of users, devices, applications, and bandwidth is exponentially growing in our industry. It's growing if you're hospitality, if you're healthcare, if you're retail, if you're corporate and enterprise, if you're in the mining and industry space, if you're in the distribution center space. It doesn't matter what industry you are. There is an explosive growth of users, devices, applications, and bandwidth. With this comes user complaints, the wireless sucks problem. So every day there's now more users saying, the wireless sucks. Can you make this work better? My son can make it work better at home. Why can't you do this? Right? So this is also a very real trend. There's unfortunately one other trend that's a truism in industry. I don't know of a single IT team in the world that has exponentially grown their IT staff. If nothing else, I've seen teams shrink. So now, how do we bridge this gap? How do we bridge the gap of mission critical user expectation and a smaller IT team? And there are 2 foundational things that you need in your systems today. That is AI and automation. Do not build a team or a network or a system today that is not AI driven and automated. And that's why this is the wake-up call. If you are guys deploying and responsible for the wireless networks in your homes, in your enterprises, don't buy a controller. That's not AI. Don't, staple chickens and hope they will fly. Don't slap another box on top of another box and assume there's AI coming. Cisco DNA is a step backwards, right? You really want to drive AI and automation. by going and leveraging the elastic scalable cloud of Amazon, and that's what the modern wireless companies do. So let's look at what the industry evolution has been. I'll use an analogy of the GPS system's evolution. About 15 years ago, 10-15 years ago, we had Garmin GPS in our car. And that was the state of the art. It took us from point A to point B, and it got us from place to place. It got us away from paper maps. The equivalent in our industry is the evolution and the birth of companies such as Airspace, Aruba, Meru, Trapeze, and these guys brought the controller architecture. Just like the Garmin GPS system, it is static. It is an act of God to upgrade the image, but it served a purpose. It served a real purpose of being able to manage large networks, right? So that's the controller industry. And then when we evolved from Garmin GPS came Google Maps, right? Google Maps simplified the one thing that was impossible to do with Garmin GPS systems, which is update the maps. The equivalent in our industry is Meraki. Meraki dramatically simplified deployment. And so Meraki, when it was conceived, was for the lawyer office and the corner bakery that was easy to deploy and just get enterprise grade Wi-Fi in a small medium office, right? It was great for deployment. But today, when we need to drive, we rely on Waze. Why did Google, after having the world's best mapping platform in Google Maps, acquire Waze? Because Waze is self-learning. Waze learns from the edges and makes the experience better for everyone. It learns, it senses from its users and makes the network better for everybody. And that's what Mist is. Mist is the world's first self-learning AI-driven network. So now let's look at what's been our journey. How did we just accidentally stumble on this thing, or did we intentionally build it to this level? How did we become of what we have become, now being deployed into the largest enterprises in the world's largest retailer, the world's largest online retailer, the world's largest social media company, the world's largest search engine company? All of them are leaving their legacy systems, are coming and now building the network of the next decade using Mist. Why? Here's our journey to the AI-driven network. It starts with data. We built a living, breathing, elastic cloud in the Amazon AWS cloud system to take incredible amounts of metadata to the cloud so we can build, we can apply data science, we can apply machine learning, and ultimately we can deliver the world's first AI-driven virtual assistant for the networking space and ultimately get to a self-driving AI-driven network. This is foundational, and it is built on a microservices architecture that you can only find in networks built after 2015, 2016, and that's what Mist is. So let's look at examples, the manifestation of data, machine learning, data science, and virtual assistants in the Mist AI-driven network. So here's the examples. So it starts with AI for us is an NLP processing cognitive assistant of the Mist virtual assistant that is able to understand and answer questions about common problems in the network. Machine learning for us came in the form of unsupervised machine learning for our location algorithms, for our throughput service level expectation. This is learning the system and being able to eliminate complex processes. The simplest example is elimination of the calibration when deploying location networks. If you've ever deployed location networks, the calibration piece is the most expensive, and consequently most retailers, most distributed enterprises have never deployed location at scale because of that element, and we've automated, eliminated that using machine learning. Deep learning for us is the crusade of a self-driving network that takes all this data. RRM, radio resource management, has existed since 2002. But AI-driven RRM is now, in 2018, only available in a MIST-driven platform. But data science, there's a lot of data science in the MIST system. I mean, I can't enumerate all the examples where we're using data science. I'm going to show you a few videos here, but we use LIFT, we use mutual information, Bayesian inference, a lot of this to come up with what is the root cause. What is causing some of these things? What is the highest probability of something being the primary vector that's causing the failures? All that kind of stuff we're going to show in the data science section. So let's start with AI. So for us, with respect to AI, it is about being able to show ask natural language questions in our virtual assistant to say, hey, what is wrong with, Sujay's iPhone experience last week, right? Process NLP and be able to come up with, is throughput the issue? What kind of correlations are happening? Is it client specific? Is it because Sujay has a corner office that he's suffering from some coverage issues? Is it, how is the band affecting his experience? How is the WLAN he's on affecting this experience? What other factors are affecting his experience? All of that we're able to be able to process and get you to an answer without you having to swivel chair. How about machine learning? I talked about this enormous calibration effort that goes on when deploying location applications, especially Bluetooth Low Energy applications. What I'm showing you here is how we machine learn about an iPhone 10, a Samsung, an iPhone SE, and how these devices behave. And we automatically come up with the path loss curve on how an iPhone 10 behaves at your home, at a Home Depot, or at a baseball game. We are able to adjust the path loss curve and be able to auto calibrate, and consequently when you today deploy the MIST BLE solution, you don't have to send people to 1500 retail store locations to calibrate their BLE. We machine learn that and auto calibrate that. That's the power of machine learning. There's many examples like that. This is just one of the examples in the MIST system. Now let's look at deep learning. Deep learning is the science of neural networks, convolutional neural networks, and the ability to get closer and closer to the processing methodology and capabilities of the human intellect. Right? So a couple of examples of deep learning in the MIST AI system is the NLP engine that's processing natural language queries, processing natural language questions. So we don't have to train the help desk teams and the operations teams and the IT teams on complex dashboard navigation, point and click, ask simple questions, get answers right there immediately. The next example on deep learning is around being able to use neural networks for coming up with a much better, more optimized channel and power algorithms. Historically, we have done radio resource management for a long time in wireless systems, but they were all static. They were based on whatever knowledge the controller had at that very moment in time. But with the MIST AI-driven RRM, we take 24 hours of worth of data, process it through neural networks, and be able to come up with the absolute best, most optimized radio resource management channel and power assignments. So the use cases have not changed, but the efficiency and the effectiveness of the algorithms with AI has absolutely changed. Right? Now, data science. This is powerful. Data science is the ability to take lots and lots of data, curate them as metrics, and be able to measure metric and monitor an anomaly detect on them. Measuring time to connect, every user, every second, their average throughput experience, their coverage experience, and then being able to say, when things are failing, when are they failing, what type of devices are failing the most, what OSs are causing the most failures, right? Being able to say, is iOS 11.0 better for you, or should you stay with 10.3? What bands are having issues, being able to see where in your network your applications are failing, your roaming is bad, what are the anomalies, where are these anomalies happening, when are the anomalies happening. The first time in the industry, a roaming metric, being able to see what types of devices are failing roaming, all of this stuff, being able to ask this natural language question and then run Bayesian inference on some of the data out there and say, what is the probability that Sujay's device is having the same kind of issues as other devices in the network. Being able to go into an individual client, do mutual information, and say, how does Sujay's device stack rank across the rest of devices? Oh wait, the Nag's phone here is having issues. Let's go take a look at that. And is it client specific? Is it systemic to the rest of the network? Is a single DHCP server the root cause? Is Nag's issue specific to him? All that kind of stuff. This is data science in action. In conclusion, there are many fakers out there. The real AI-driven network will deliver, will not do it in PowerPoint. So please try Mist in your enterprises. And I don't believe we've ever gone into proof of concept where we've had to decommission our APs. We've always, once a customer sees AI in action, they will never go back to a Garmin GPS system. They will buy Mist. Thank you very much, and appreciate the opportunity to work for your network for the next decade.